Creating a smart contract. Now, for this video, I don't want you to focus on any technicalities. I'm simply going to create a smart contract, deploy it to the network, and interact with it on Etherscan. The purpose of this video is to show you the process. Later on in the course, we have a whole section covering everything we're working with over here. Currently, we are on Remix. This is an online IDE, an integrated development environment for creating smart contracts and deploying them to the blockchain. Here we have a small Solidity contract that does nothing at this very stage. You can see that the contract section is empty. On the left-hand side, the file's name is HashLips namesetter.sol. All Solidity files have a .sol extension. The contract we are creating is very straightforward and simple. We will be able to update a string, a name, on the Ethereum network changing its state after we have deployed it. This is also to show you that contracts don't always need to be very complex and big, tokens and so forth. It could be simple contracts like this one. To start off, I'm going to give this a variable, and this will be of type string. We'll discuss this later on, and I'll call this name. The name is now a storage slot available for us to update it. We can update variables with functions. So I'm going to write a function and call this setName. This setName will take in a string. This is the same data type as the name variable. We'll use memory allocation for this, and we'll say this will be our new name that we are going to pass into this function. But what does this function need to do? Well, it's very simple. We would like to set our name variable at the top equal to the new name that we are passing into this function. In order for us to call this function, we need to let the compiler know that this is now public, right? Because we want to access this after we have deployed the contract. Keep in mind, anyone can now call this function on the smart contract and set the new name, because we don't have any rules specifying who can call this function, but that is fine for our use case. Now, in order to read the name, we can either create a new function that says getName, or we can simply make this public, like so. Now that we are done with our smart contract, we can move over to the next step. That is compiling it. We are going to use this compiler, but this will all be explained later. For now, I'm just going to test, and it looks like everything worked fine, which we can see from this green tick over here. It compiled successfully. And that means that we can now have access to our ABI and the bytecode. But this is not on the blockchain yet. It just means that our contract has compiled successfully. Now we need to send it to the Ethereum network. Before we deploy the contract, I just want you to know that usually you can write tests to test your smart contract before it's deployed. And that is a very good idea, seeing that we cannot change the code after it's deployed. Okay, so let's go to the next step. Here we can deploy and run transactions. Now, before we deploy it to the real blockchain, let's just deploy it locally on the browser. To do so, I'm going to make sure that I'm on the Remix Virtual Machine, which is going to emulate the Ethereum Virtual Machine right here in our browser. I will select the contract that I would like to deploy, this one, and hit deploy. As you can see, we have a new deployed smart contract. We can open this contract up and see that we have this function and our variable that we can call. Now we also see this green tick with some information. This was the transaction that was sent to our virtual machine on the browser in order for us to deploy the smart contract. By now, you can probably recognize some of these fields. For now, just understand, this was sent with the bytecode to our EVM in the browser to test this. We can also test the functionality by calling the name and seeing that it's empty. We can set this to Daniel, call a transaction, and then call name and see that the new name is Daniel. Notice when we click on a function like this, that there's a transaction. And if we open the transaction, we can actually see the amount of gas that's consumed to process this and store this state. We'll talk about gas in the next video. But why isn't MetaMask popping up and asking us to pay some gas? Well, that is because we're using the browser's EVM and they give us some account with some value in it. Over here, we can see 99.999 because the gas was deducted. We started off with 100 Ether. But this is all playful and fun and the test work. So now let's do the real deal. To deploy the smart contract to the real blockchain, we need to switch the environment. I'm going to click on this and I'm going to say injected provider MetaMask. MetaMask will then pop up and ask us which account to connect. I'm going to connect account 1 and click on next. At this point, we need to make sure that we have some funds. And we can see this is our account and the funds is 0.0148. This should be more than enough to cover the gas fees for me to deploy this code to the blockchain. Okay, so we have our injected provider. We'll talk about providers later in the course. We have an account connected. And now we need to select a contract. And when we click deploy now, this will be the real deal. Let's clear the console and then click on deploy. Now Remix will tell us roughly what the gas is going to be. We will have a look at this screen in the next video when we discuss gas. Let's click on confirm. MetaMask will show up and tell us it will cost $8 to deploy this contract. Let's do it. So we click on continue and it takes a bit longer than the browser EVM because this is the actual blockchain and a node is now going to take the transaction and validate it, and so is all the other nodes. And now this is actually on the real Ethereum blockchain. On the left hand side we can see the deployed contract, but let's not interact with it here. Instead, let's copy its public address and go to Etherscan. On Etherscan, what we can do now is paste our address in here and search for it. And here it is. This is our newly created contract. This is the public address, and we can see the very first transaction was a contract creation transaction. If we click on the contract, we can only see the bytecode, not the ABI and not the actual Solidity code. But that doesn't really matter because the smart contract doesn't live on Etherscan. We can still interact with it as long as we have the ABI and we use code. But it would be nice to interact with our smart contract on Etherscan. In order to do so, we need to verify and publish so that we can tell it what the code looked like when we deployed it. Let's click on verify and publish. This will take us to a few steps. Here we need to select things like the compiler type that was used, the license, and so forth. We can get this information from Remix. So if we go here, we can see the compiler used 0.8.7 and here is our license to the file. So back here, we can simply say that this was a single file, and for the compiler, we used 0.8.7. So let's go there. For the license, we used GPL3. Okay, now let's continue. Now we get to a page where we have to specify if optimization was used and provide the actual code. On Remix, we can see that no optimization was enabled. So we say no, and let's copy all the code, go back and paste it in here. We can now go down, and if we had any constructor arguments, which we don't because we didn't have a constructor, we'll touch on that later on, we can paste it in here. For now, all I need to do is tick this box and click on verify and publish. This will bring us to the successful screen, hopefully, and this is how it looks. We can now see the entire bytecode as well as the contract's ABI. Now we have everything. So if we now go back to the contract, we can see a little tick mark. This means that we have verified the code and the bytecode matches up. Now, like all the other contracts, we can see the actual code, we can see the ABI and the creation code. We can also now click on read contract, and we only have one function and we can read. Currently, it's empty. But if we click on write, connect our wallet, which is MetaMask, and now that we connected, let's set our name. I'm going to set it to Daniel. Now I'm going to write, and this time I need to pay gas every time I need to make a transaction. Let's pay for the gas fees to do this operation. The EVM is now going to kick this off. Validators are going to take this, verify it, and add it to the blockchain. And once it's done, we should see our name now when we read from the contract. This all depends if the transaction was successful. We can see it was, so if we click on this over here, we can see that it was confirmed, and we can even view it on Etherscan. For now, let's leave it and go to the read contract, click on name, and we can see that I updated the Ethereum state to show my new name. Lastly, if we go to the transactions of this contract, we can see that 1 minute ago, the set name method was called, and this is a transaction, showing you that every single change in the Ethereum network is a transaction. And that is how the process works. I also want to let you know that this contract is now public. So if you go to Etherscan and you search for this address, you will see the exact same contract on the blockchain. And it is going to live here forever. You can even go ahead, click on contract, and read and write data if you want to.